Okay, yesterday we talked about similar figures, so today we are going to start the first of our four transformations. And today we're going to talk about dilations. So a dilation is a transformation that reduces or enlarges a figure. The scale factor is the number that is multiplied by an object to make it smaller or bigger. If the scale factor is less than 1, then your figure is a reduction, which makes it smaller. If the scale factor is greater than 1, then your figure is an enlargement, which makes the shape bigger. Okay, so how are we going to identify what a dilation is? Well, with transformation, we use a lot of algebraic expressions or a rule. And so in this case, K is our scale factor. Remember, our scale factor is the number that we multiply by to make it greater or smaller. And so how we express this rule is xy is transformed to kx, ky, where k is my scale factor or a number. Okay, so how am I going to do this? I'm going to label the figures original and new. My original will be labeled by a variable, and that variable might just be the letter A. My new might be labeled as a prime. Okay, so we're going to find the corresponding or the coordinates of two corresponding vertices or find the measure of two corresponding sides, which means we're going to find the same 2 points and the same side. You're going to create your scale factor by making a fraction comparing the new to the original. And we write that scale factor as new over original. Okay? All right, so let's determine the algebraic expression used to dilate the figures below. So let's look at the first one. The first thing we want to do is identify the type of dilation. Is it an enlargement or is it a reduction? So I'm going to look at my two triangles. I notice that this is PQR and this is P prime, Q prime, R prime. Anytime I say prime, this is my new. This is my original. So here, I know from my original to my new, it gets bigger. So this dilation is an enlargement. Now I need to determine the scale factor. So I can use the scale factor or determine it by picking two sides, corresponding sides. So I'm using P prime, R prime, and PR, which is new over original. So P prime, R prime. I'm using the same corresponding side, PR. Well, these are letters, I need numbers. So I'm going to count P prime, R prime, and I get 1, 2, 3, 4, 5, 6. So 6 goes in my numerator. The measure of PR is 1, 2. So if I reduce 6 divided by 2, my scale factor is 3. Now we want to write a rule. So what is our algebraic representation? So xy transforms to 3 times x and 3 times y, which that means that my original is 3 times greater now. Okay? All right, let's look at the one right beside it. Identify the dilation. So I'm going to look at PQRS, and then I have P prime, Q prime, R prime, S prime. Well, with me saying that, this is my new and this is my original. So from my original to my new, it got smaller, so this is called a reduction. Now we need to determine our scale factor. So I have two corresponding sides that are straight that I'm able to count. And remember, it's new over original. So I'm going to use Q prime, R prime, and use the corresponding side for QR. So the measure of Q prime, R prime is 1, 2, 3. The measure of QR is 1, 2, 3, 4, 5, 6. So here, if I reduce 3, 6, it's 1/2. So my scale factor is 1/2, or you may see it written as 5/10. So what would my algebraic expression be here? XY is transformed to 1/2 X, 1/2 Y. Today your work is in Canvas on dilating on a coordinate plane. So go in and do that and submit me your paperwork.